Hello everyone, hope you all are fine. Thank you for taking out your precious time for my today's webinar conducted by Kyrotech Solutions, and I will make sure it will be a worth for you. In today's webinar, we are going to cover the topic of designing of press tool, in which I will take one example of progressive tool along with its strip layout design. I hope everyone is clear with my voice and my screen as well. Even though to experience the best, you can click on the full screen option from the view tab and also close the chat panel for now. And by chance, if you couldn't make it for today webinar, don't worry, we will be recording this and you can go through later on our channel of Kyrotech Solutions. So let's begin with a brief introduction. I am your today's host. My name is Suhas Gunja, currently working as a technical product manager at Kyrotech Solutions. And to talk about my professional background, I am a proud mechanical engineer with an experience in tool and die making from Tata Motors Pune and a recent experience as a tool designer at Wadokar Group of Companies. We, the member of Kyrotech Solutions, provide a total CAD CAM and CAE solutions for the manufacturing, architectural, and infrastructural industries. Also, we are the part of Hexagon community, which is one of the well-known manufacturing intelligence around the globe. VZ is the software introduced by Vero, now acquired by the Hexagon. VZ is one of the well-known software which is specialized for the tool and die designers, and it offers an end-to-end solution for the design and manufacturing of progressive and stamping dies. It includes almost every concept of tool designing, from blank formation with FEA simulation, unfolding part or a flange, tool assembly, and automated 2D drafting of the design. In today's webinar, I will cover the core part, which is strip layout design and tool design. We can easily prepare strip layout design in VZ by unfolding the part one by one in different stages, or we can prepare unfolded stages separately and then insert accordingly into the strip. To define stages of the strip layout will depend on individual skill of the designer according to his respective experience. I will show you how easily we can prepare the strip design in this software by accessing only the necessary parameters along with the bending and shearing calculations. I will also cover the part of tool assembly design for the respective strip layout design to be followed. VZ saves a lot of time by working only on necessary aspects of tool designing, which includes readily available tool templates, inbuilt standard element, easy punch creation, and many more. Now let's start with our actual demonstration. I won't be able to solve your queries in between due to less time in hand. If you have any doubts in between, you can type them in chat panel, which I will definitely read them out once the demonstration is over. Let's start with our demonstration on VZ now. So this is how the GUI, means the graphic interference, looks like of the VZ, and I've taken this part in which I'll cover the almost every operation like plunging, flanging, and piercing, and the blanking as well. Let's start with extracting the skin. Select this part. You can also select the material whichever you want. I will select the default one. Click OK. Now I will try to unfold this plunging operation. I will first detach it to get the blank of that the plunging part. Detach it. Now I will show the only that part. Now let's unfold it with the help of VZ blank module. Select the part and click OK. You can see the only necessary parameters over here, also the thickness it's detected automatically. Now I will constrain few edges. I don't want these edges to be changed. I will select the plane where I want the blank, click on blank module. Here you can get the all parameters of the final blank. This is how we got a blank unfolded of the plunging operation. Now let's delete the unnecessary part and just show the whole part. Now I will join this both unfolded part and the previous part. In this way we got our first operation unfolded. Now let's extract the skin again and try to unfold this flange operation. For this I will need this binder surface. So go in surface, extend surface, select the edges from where you want to extend it, extrude a bit, let's say for 7 mm. Now go to flange unfold operation, select the radius and the edge properly, click OK. Here you can see that it's calculating according to the mesh of the part. Now select the binder surface which we created, click OK, and in very less time you can get your blank unfolded or the flange unfolded. You don't have to waste time in surfacing in this way. Now let's simplify the part so that we will get the proper edge. In this way we got our another step again. Now the only linear flanges are remaining, so let's extract the skin again and just unfold the linear flanges with the help of this command. Select the edge and the radius, click OK. Edge, radius. This is how easily we can unfold the linear flanges. In this way we got our blank. Now let's go to the strip layout design. Let's prepare. First we will add this thickness to this both and delete the skin which we extracted. I don't need them now. Now let's go to the strip layout design, select the blank and select the origin. Let's get to the top view. In this you can also create the double part. Let's take one mirror part for the example. Select the origin, place it somewhere. I will place it here, click OK. In this way, now let's change few parameters of the strip design. For example, I will give angle to both of them, for example 10 mm, 10 degree. Now I will define the stages, 10 stages. Length before origin is 20 mm. Step is nothing but the pitch between the two parts. I will just remove the decimal points. 40. Strip of the width. In this way, click OK. You got your 10 stages. Now let's add all the punches. First add internal punches, for example piercing punches. Now let's add the maximum sheared punch. I will increase the lower upper and the lower gap, let's say 3 mm both side, click OK. Now I will cut this punch into 3 so that I will obtain my part of punch, click OK. I will also cut the lower side into, click OK. Now I will shift this center punch to the last stage as a part of punch, the second last stage. In this way Now let's simulate our strip. Let's see how it looks with the cutting punches. Okay, this is how our strip looks like. Now let's add the forming stages. I will add this stage, select the origin. In step 4, I will add this stage to the step number 6, and the final I will add in the step number 8. Click OK. Now let's simulate with our forming stages. In this way we got our strip design. Now let's add bending punches to it. Select the surface of the forming. Click OK. Let's add the die insert as well. Select the lower surface. Select the proper direction. Click OK. Now let's edit the shape of the punch with few modeling commands. For example, I will give a proper shape to this both punch and the die edge in this way. There are a lot of quick modeling commands in VZ. Now let's add another flange operation punch. Select the faces and the radius. Click OK. Now select the flange side. Now change the direction of the extrude. Let's say this direction. Decrease the length. Give a proper shape to your punch. Now let's replace and this face with this with this, and hold this with this. Now let's cut the body into perpendicular shape from the center at this side as well. Now delete the unnecessary part. Come to the lower side. Give proper shape to the lower side as well. Replace face. Increase this face length. Now I will join these both parts. Now I will move the face of the length of this flange operation a bit and give a proper fillet to it. Let's say 1 mm radius. Okay, in this way we got our flange operation punch. Now let's add the die insert of the flange operation as well. Select the faces and the radius. You can create whatever shape you want. It totally depend on the designer skill. I'm just showing you the example. In this way we got our all bending punches and dies. Now let's add the die insert as the separate, because I've created that with the help of punch. Add elements of the die insert to the separate layer. Now just mirror these bending punches and die inserts to the opposite side. Select the center of the strip, give the proper direction, name it as copy. Okay, in this way we got our bending punches and die inserts. Now let's go to the strip tool design part. Let's close the strip design. Now move to the tool design part. Click on progress tool. Select the strip design which we have created or the project. You can get the readily available tool templates over here, And you can also create your own template and say I will select this template for example, and you can now change the parameters of this tool whatever you want. Let's go to the side view. Now let's change few parameters. Let's say punch height for 80 mm. Go to the top assembly, top plate, change the thickness for 40 mm, width let's say 320. Now get to the middle part. Let's change few parameters of this pressure pad. Height 28. Let's reduce the slot height with 10. Okay, now let's go to the bottom side. I will increase the width of the die plate a bit. Let's say 215. Okay, I don't need this bottom back plate. I will just remove it. You can see this bottom plate will get attached to die plate automatically in this way. In bottom plate, let's change the width and the thickness 45. Okay, now this looks like a proper progressive tool with proper parameters. You can save your this template as well as a new, or you can create your own. Click OK. Now we will extrude our punches. Go to the punch extrude option, select the cutting punches first. Click OK. Click on the subtract auto subtract element. Now just click on the extrude punches option. We will check in the side view, select the punches and click on extrude punches. You can see that die cavities are automatically created. We don't need to create separately. You can change parameters with thickness and all. I will add a stock to this so that it will give a proper shape. Now I will add a step head punch. I will create them as a step head. You can change the height. You can see step is added to all punches. Click OK. Now in this way we have extruded all our cutting punches. You can also change the cavity parameters whatever you want. I will add a riser block to the bottom assembly. You can also add custom plates of your own. Let's add a riser block. Select the center, select a riser block, click OK. In this way, now let's change the width and the riser distance. Let's say 130. Let's make it 120. Okay, so that our slugs will be removed between the risers. Let's go back to our extrude punches option, extrude them again. Now in this way, let's select the bending punches. Now select them, name as bend, extrude them as well. You can see cavities are not prepared for the bending punches because they don't need die cavities. Also add head to them. In this way we are done with the extrude punches. You can also change the cavity parameters. For example, let's change cavity parameter of this piercing punch. Select the die cavity, add, let's add a draft to it, increase the angle. You can see changes in the design. I'm giving a 4-degree angle. You can also change the cutting height. Every parameter can be changed with in the VZ, whatever you want. You don't need to draw sketches and extrude everything or delete from the modeling processes. Now let's create an assembly. I will create an upper group, let's say upper assembly, name it as upper assembly, and I will add top plate, top back plate, punch plate, super plate, and the punches. Yes, click OK. Add bottom assembly as well. In bottom assembly, die insert, riser plate, bottom plate, and the die plate. Okay, now let's edit. In this way we got our 3 assembly. Now let's edit few die plate with few modeling commands. Select the bottom plate and the die inserts. I will extrude this die insert till the bottom plate. Select the bottom faces of the die inserts. And I will extrude them till the bottom plate so that they become a proper inserts. Now on your die plate, now let's delete the upper portion of these die inserts after the forming process starts. Let's reduce the thickness bit. Let's on the die plate, I will select this area to be reduced thickness a bit. Extrude this profile with 8 mm. Okay, now mirror this part to the opposite side as well, so that I can subtract this from the die cavity or the die plate. Now let's subtract this both from the die plate. Select the die plate and the elements to subtract. Click OK. In this way, now the strip will be properly adjusted on this surface. Now I will just give a chamfer to this edges. Let's say 4 mm. Let's do it 5. Okay, in this way we got our die plate, and in this way strip, due to the forming stages, I reduced the thickness of the die plate a bit from where the forming has started. Now I will divide our die plate into 3. Let's cut it into 3 parts. Select the direction, created 2 parts. Let's cut this into 2 halves. In this way. Now let's create the cavity for this die inserts. Go to the cavity option, select the, sorry, first we have to select the die plate, then the elements which are going to subtract it. Click OK. In this way we have created the die cavity. Now let's have a look at our whole assembly, how it looks. Now let's add few standard elements to this. You get all the standard element library inbuilt in this software. Let's select the Mizumi and let's try and add guide pillar and the guide bush. For example, I will type the code of the Mizumi, which is MYP, plain guide post set. Select the start plate as the bottom plate, end plate, and just give a point where you want to place, let's say, X and Y. In this way you got your pillar. You can change all minor parameters of this. Let's, for example, I will change the length of the dowel to the upper and the lower. Subtract element, click OK. Now let's mirror this guide pillar and bush to all other sides. You can also shift a bit, you can also translate it. For example, let's translate it to the Y direction a bit and take it to the corner. You can see the cavities are automatically shifted along with it. You don't have to edit it separately. Now let's mirror this part to the other side as well. Select the center. Let's mirror this both elements to the opposite side. And now just subtract the cavities. For the Pokayoke purpose, let's offset one pillar and bush. It is a good practice. Usually it is useful for the manufacturing or the assembly purpose. In this way, now let's subtract these element cavities with single command known as subtract element cavities. Select everything, click OK. You can see all the cavities have been created of pillar and bush. Now let's go to the upper assembly and add few standard elements to this. First I will add the stripper bolts. Let's type the code of stripper bolt, which is MSB. Select start plate as top plate, stripper plate, and just select the point. Let's say 15 mm from X and Y coordinates, minus 15 and 15 in the Y. Select the M12 bolt, subtract cavities, click OK. Let's have a look at side view. We will add the stroke length to it, let's say 15 mm. You can see. Now let's mirror this part to all other sides. Select the center, give proper direction, select this board, oops, select this board and mirror it to the opposite side as well. in this way. Again, subtract element cavities. Click OK. In this way you got your stripper bolts added. Now let's add coil springs. SWM is the code for coil springs of the Mizumi. Let's select start plate, end plate, and I will place few points for the coil springs. You can add according to your calculated load, and also you can place the points properly wherever you want. I will just place it due to the time constraint. Select the diameter whichever you want. You get all standard diameters in this. I will select the 30, subtract cavities, click OK. In this way springs are added, stripper bolts are added. Now let's get to the bottom assembly. Let's add few cap screws to the bottom assembly as well. Go to the cap screw option, select the top plate, bottom plate, and place the points wherever you want. Click OK and just change the diameter. Let's take M10 bolt, subtract cavities, click OK. Now continue with your command and select other points as well. Only the start plate will change in this. They will ask for the start plate again. Click this as a start plate. Same for this. I will hide everything else so that I will place my point properly. Now select the start plate as this. In this way all our standard elements are added. Almost everything is added, only the dowel pins are left. You can add them as well in the same process. Now let's divide our standard elements into upper and the lower assembly as we divided our plates. Go to the assembly, add a new node. Let's add a node in bottom assembly as bottom standard. I will add std, add elements, select all bottom elements. In this pillar will also come in bottom side. Select the pillar, click OK. In the same way add elements of the upper assembly, upper standard std, OK. Add elements, select all other elements. In this way we are divided our standard elements into upper and the lower assembly. Let's have a look. Almost I have completed the whole die designing. This is the strip layout design, the upper assembly, lower assembly. You can have a look at the solid view. In half an hour I have completed the whole die designing. People spend a lot of time, days and hours in this. You can also have a look at dynamic section view, in which you can see that element cavities are created for every punch and the die and the standard elements. You don't have to waste your time separately on the separate plates. In this way I have completed the whole die assembly only in few minutes. Just the finishing part is remaining. This is how easy it is in this software. For the die designing, it is specially made for the die designing, so that you can only access the necessary parameters. You don't have to waste time in modeling. Now let's get back to our presentation. So in next 3 to 4 minutes, I will try to cover the questions which are on the chat panel. If you have any queries after the session or you want to get in touch with us, you can contact me on the details mentioned on the screen. Let's take the questions by attendees one by one. First is that, can we unfold a blank in this software? Yes, definitely. Rather, it has a special module for the blank forming, and also we can simulate it according to finite element analysis, which is mostly known as FEA simulation. Next question is, can we get the training for software after the purchase? Yes, the complete training programs will be conducted by us, and a complete technical support will be provided from us to the every minute queries of the customers. Generally, in some cases, people buy the software and don't make the full use of it due to the lack of training and support. But this is not in our case. We give a complete support. Let's take another question. Can we edit the standard elements after inserting once in it? Yes, we can change the parameters of the standard elements anytime you want. Let's demonstrate one example of this question. For example, I will go back to our software. I will try and change the diameter of this pillar or this both pillar. Go to the edit elements, select this both pillar, go to edit instances and change the diameter whatever you want. In this way, you can access all the parameters whenever you want. In this way, all cavities are automatically changed according to the diameter. So next is, can I get the recording of video? Yes, I am recording this currently and I will soon upload on the YouTube channel of our Kyrotech CAD Cam Redefined. I have more questions on the chat panel, but due to time constraints, I won't be able to take them all. But I will definitely answer them on their personal mails. I will stop the question answer over here. So again, thank you for giving me your time and listening to me, and also leave me a feedback on this webinar. Please get in touch on the details mentioned on your screen, or you can visit our website at kyrotech.in. Thank you and have a great day ahead.